with logarithms, we have some properties, and these are the properties here. We have the product property. Log a of u times v can be written as log au plus log av. The quotient rule is log base a of u divided by v, and we can separate it as log a u minus log base a v. And then we have something called the power rule. Notice we have an exponent here, so the power rule will allow us to take this exponent to the front of the log, and then we would have n times log base a of u. And these properties hold true with the natural log as well. So notice here, natural log of u times v can be written as natural log of u plus natural log of v. So in example 2, we want to write down what this comes out to. So for the first one, we would ask ourselves what's going on in the parentheses here. We're multiplying, so that means we're going to use the product rule. So I can rewrite this as log base 6 of 7 plus log base 6 of 11. If we look at the next one, we have log 100 times x. The base here is 10, since we don't see a base, and 100 and x are being multiplied, so we can rewrite this as log 100 times x. So this would be log 100 plus log x. However, here for log 100, we can simplify that further. So log 100, you can put it in your calculator since it's base 10. Or you can use the ideas that we learned before. So log 100 can also be, there's a 10 here. So basically, what power does 10 have to be to give us 100? And that's 2. And so this would be our answer. And so you can convert this right here to exponential form. So you would have 10 raised to the power of x equals 100. And so the power would have to be 2. For letter C, notice that 23 and x are being divided. So we can use the quotient rule and separate this as log 8 of 23 minus log base 8 of x. So let's try a couple of more examples. So we have log e of 5 divided by 11. Since this is being divided, we can rewrite this as natural log of e to the 5th minus natural log of 11. So in the previous section, we saw that natural log is the same as log base e. So we can rewrite natural log of e raised to the 5th power as log base e of e raised to the 5th power. Since they have the same base, then our answer here is just going to be 5. You could also put it in the calculator. You could have written it as natural log of e to the 5th power and you can see it comes out as 5. Okay, so anytime you have natural log and e, your answer is just going to be that exponent. On the next one here, we have log 8 W4. So notice that here the base 8 and W are not the same. So we cannot apply the same rules that we did over here. And so this is where the product rule is important. Multiplication as log 8 of w times w times w times w, which would then be log 8w plus log 8w plus log 8w plus log 8w. So if we add these four together, now we're going to have 4 log 8w. So that's if we don't use the power rule. However, the power rule allows us to look at something like this. Let me just rewrite it. And the power rule tells us that the exponent we're going to bring to the front. So we're left with 4 log 8 of w, which is the same answer that we got here. So to save time, we can just use the power rule instead of rewriting this into a multiplication and then separating it to addition. So let's look at letter F. So here we have natural log of the cube root of x. So 1, I can rewrite this as natural log of x raised to the 1/3. The cube root can be written as a exponent of 1/3. Now I can take this exponent to the front. So I'm going to have 1/3 natural log of x. Okay, so these are the three properties that we can use to help us simplify in the next sections.